Okay, g'day, how you doing? Alright, so I'm doing a demonstration for chapter 4 of CCNA 3 today, and so the topics are Ether channel and hot standby routing protocol, or first hop gateway of redundancy. So basically we've got a topology here, you can see part of it. So we've got an ISP router, and so we've got two internal routers, and within that I've actually defined two VLANs, and so there's VLAN 10 with the address 192.168.10. whatever it might be, and also VLAN 20, so 192.168.20.x, and so from there, basically, so that's the setup. And so when it comes to the switch side of things, we've just got a gigabit link between each of these core switches and the routers, and we've got double cables, and these are fast Ethernet cables running between the two core switches and to the other switches, and so access layer switches. And so as you can see, I've got a total of 6 cables, but only 3 of them are active at the moment, and so that's something for Ether channel to try and fix. And so we've got 10.0.0.9. Everything is configured to run. I just haven't, of course, done Ether channel or HSRP at the moment. So we'll just ping 10.0.0.9 and see if that works. We might lose a packet through ARP or something like that, but should get through, and it does. And so if we look at IP config, this one it's a VLAN 20 host, number 22, and of course is using .2 as its gateway. And so I could have used .1, it would have made next to 0 difference, but I'm using .2. Now, so if we look at the switches, I think I've set up all 4 of the first Ethernet ports to be trunk ports. I've also set up the gigabit ports to be trunk ports as well. That's why they don't have VLANs listed on there. And so port 10 is on VLAN 10, port 20 is on VLAN 20, just because it's easy to remember. And so all the switches are pretty much identical, other than which cables are plugged in where. And so, why did that disappear? And so, yeah, again, first 4 are set aside for trunk. The 2 gigabits are set aside as well for trunk, and port 10 and port 20 are in VLANs 10 and 20. So they're all pretty much identical, just so I can copy and paste. Makes it a lot easier. Oh, yeah, and so on. So they're all identical at the moment. So let's have a look at what we're going to do. So this is just the configuration I've done up until now. And this is creating the VLANs, creating the trunk ports, and so on. Now, so first thing we'll do is we'll set up Ether channel. And so with Ether channel, you need to, of course, make more than one interface a member of that channel group. And so I've just used the interface range command. I'm just doing 2 interfaces, as you can see. Now, because these 2 core switches are going to have 2 separate Ether channels, they need to have 2 separate channel groups. And so the first 2 Ethernet ports are going to be parts of channel group 1, and then ports 3 and 4 will be part of channel group 2. And so once you've done these commands, you've actually created 2 logical interfaces that will, of course, be available for you to configure. And so they're going to be interface port channel 1 and interface port channel 2. And so once you've got that interface, you then need to set any settings you want for that particular port. And so in this case, all I'm doing is just setting them as a trunk port. And that is enough basically to have a look. So I suppose if we look at one of these switches now, if we do EN show Ethernet Ether channel, summary, there's no summary, there's nothing's happened yet. So I'll configure the switches. So I'll do a copy and paste. Copy. And paste. And so going back to where it was, sorry, gone too far. And so after conf t, we do interface range 1 to 2, create that channel group. And so I've used the command active, and so active and passive are ways you can do it, of course. Active, of course, is just, I really want it. And so you can do active on both ends and it'll work great. And so again, so both channel groups are going to be active. And as you can see, there are no errors. Now, if we do that show ether channel summary again, it's actually got the two channels. And so the status here, SD for both, means it's S means it's a layer 2 or switched ether channel, and D means it's down. Now the reason it's down is I've only done one. I've only done this switch at the moment. And so once I configure this switch, we will start to get some port channels coming up. As you can see, the ports have already gone red. So let's have a look at show run. And so as you can see, we've actually got this interface port channel coming up. Switch port mode trunk, of course, is the command I'll put in for that. And then, of course, the actual physical ports are now members of those channel groups, as you can see there, channel group 1 and channel group 2. Now, ether channel is still sorting itself out, so I might actually speed up time a bit. And so now, here we've actually got both links, or both physical cables now active, as opposed to the rest were just one at a time. And so now I've doubled the bandwidth between this switch and this switch. That's pretty cool. So if we look at this switch here, and we do the show ether, show ether channel summary, it's now got two defined. Of course, the one going over to this way isn't configured, isn't working yet, so its status is down because the other end isn't configured yet. But you can see the one that's actually goes between these two, S, again, as we said, layer 2, U means in use, or I normally think of it as up, but anyway. And so we've actually got that going now. And so basically we just need to go through all these switches and configure the port channels. And if we go through here, and so I've sort of rushed through and done it. We'll just sort of speed up time a little bit. And as you can see now, 6 cables, all of them are in operation. And so if we look at this one now, when we do the show ether channel summary, they are, both port channels are now defined, and they are both in use or up. So that seems like a good outcome. Oh, wait a minute, we've got a timing out again. It's probably spanning tree. Of course, we're basically tricking spanning tree and treating these two cables as one, and so they're one link now. So I suppose we can always try this, make sure that we can still ping where we could ping before. And we can. So I haven't broken anything. That's half the battle, is not making it worse. So that's ether channel, and so that's working quite nicely. So you can do show ether channel or show ether channel summary, but the summary, if it's all working, the summary is certainly enough information. Now, next thing is HSRP. And so we're moving up here now. And so if I hover over that, now it'll work. as you can see, I've got VLAN 10 and VLAN 20, and so this one's got .1. This one's got the same VLANs, but of course it's .2 on both subnets. And so basically we'll go in and do this configuration. Now, normally you would do standby version 2, but because I'm demoing on Packet Tracer, that's not an option. It doesn't actually allow you to change the version number. So you're stuck with version 1. Now, what I'm going to do is this router here, I will make the primary router or the active router for VLAN 10, and I'll make this one the active router for VLAN 20. And so looking at this first VLAN 10 configuration here, so we go into the sub interface. You would set version 2, but that doesn't happen. And then you do standby 10, you give that virtual IP address, that one that will be shared between the routers. So we've used .1 and .2, so we'll use .3. And then we'll set the priority to 200. I think by default it's 100. It's been a little while since I did the other video. And so what that means is this would be the preferred active one for the VLAN. And so then the last command there, preempt, says if this router is up, I want it to change instantly to be this one being the active one. So without that preempt command, if the other router would have boot first, it would become active and it wouldn't actually change until router 2 died. And so this is a way of sort of getting it to work the way you want it to work all the time. So as I said, we're going to make router 1 the active router for VLAN 10. Of course, we will have it participating in the HSRP for VLAN 20, but it won't be the preferred active router. And so, again, all you need to do is set the standby or virtual IP address. And so, as you can see, I've called. You have to give a number to identify the different ones, and so we're using 10 for this because it's VLAN 10. Why not? And we're using 20 for this one, for VLAN 20. And so all you need to do actually to get standby running is have this command in there, standby, the number, and then away you roll. All right, so on VLAN 20, on router 2, VLAN 10, we just do the minimum configuration, so it will participate, but it's not going to be the primary. But on VLAN 20, of course, router 2 is going to be the preferred active router. And so again, we set the virtual IP address, we set the priority to be higher, and so that will be the preferred one, and then we do the preempt to make it happen whenever it's up. And so that's basically what we're doing here. So I'll copy and paste this and put it into router 1. Okay, it doesn't look like any errors. So because I've got this exclamation mark there, it just turns it into a comment, so it ignores it. And so no complaints. Now we should actually get some status messages saying that it's going to be it's going to end up being active for both, because of course I haven't configured router 2 yet, and so it's not playing that mode. But here we go. So we've got VLAN 20, or group 20 and group 10 and group 20 are up, and they're both active now because it's the only router that's been configured. So what I might do is I might do debug standby, that's packets, I think. So I'll just do that. Now our machine is sending hello packets, and so we'll just go back to that a little later. All right, so here we have router 2. We'll do that, get it going. And I'll put the config in for router 2. So that's gone in, no errors. And so it has gone active on VLAN 20 because we've done the high priority and the preempt. And so that looks like it's working pretty well. Now, if we go back to this router 1, we'll have actually got, we might undebug all now, just because I want it to stop from scrolling. all didn't go in apparently. Now, I've got a few of these that happened while I was configuring the other router. So here, this is probably when I configured the other router, and you can see that this has now gone to standby mode because the other one is the primary router and we've got preempt. Now, of course, there is another command. You can do show standby. This will show you the status for it. And so here with group 10, the state of this router is active because we've got the preempt. And so its priority is 200 and we've got preempt on. Preemption is enabled. Active router is local. Standby router is the other one, so it knows who it is. Its priority is 200 and it's been configured as 200. Now the other standby, so VLAN 20, it is stated standby because the other router has the preemption. And so you can see the preemption is disabled on this router for that VLAN. So you can see that there's a virtual MAC address that's been created as well, and so of course it's noting that that's the virtual IP address, and yeah, so all good information, and so it's working the way it should. So of course if we look at router 2 and do show standby, it will of course be the inverse of that, in that VLAN 10 will be standby because the other one is the one that's active on that. And there's no preemption. Of course here, VLAN 20, it is that one and preemption is enabled. And so it's all looking as it should. All right, let's just play around with our host now, make sure it all works. And so this is the one we used before. If I do up arrow, I can still ping. Now, there is a problem. So it's not really a problem, but it's less than ideal. I've still got the VLAN, the gateway set as .2, so the actual physical interface. And so we're not actually using the benefit of hot standby routing protocol at the moment. And so what I need to do is I need to change the gateway to be .3. I do hate the way that happens. And so now if we look at IP config, you'll notice that it's changed to .3 as opposed to .2. So if we do the ping, it should work as well, and it does. Now it all seems to be very, very happy. I might just copy that so I can use it on the other machines. Copy. So here, of course, this one needs to be 3. This is the first time it's pinged, so I might need to do an ART request first, but all good. Again, this needs to be .3. That was nice and quick. And I'll set this one as well. Oops. It's not what I meant to press. And that works nicely as well. Have a look at that. So that is working quite nicely. Thank you very much. Now, and so if we do ARP -A, if we look at this address, that's the MAC address that it has for its gateway. Let's go back to the router and see what that was, I think it might have been VLAN 10 host, yeah. So VLAN 10, virtual MAC address of that looks the same to me. So it's all a very, very happy little setup. So that's pretty much it for HSRP. Now, of course, the things to remember are how the priorities work for HSRP. And so, as I said, 200 will make it the primary, and preempt will actually say whenever this one is up, we will make it primary. Because without the preempt, it will just stay whatever it is, no matter what the priority is when it comes up. And of course, when it comes to Ether channel, you've got to make sure that you have different group numbers if these channels are going to be going to different switches. And so that's why we've got channel group 1 and channel group 2. And so, of course, you've got to have the right mode. And so active will, of course, mean that it will want to be in an Ethernet channel. All right, so I think that's pretty much covered what I was going to do. So that will probably be enough of that. And so that's a basic rundown on how you use HSRP and Ether channel. Now, of course, when it comes to Ether channel, I probably could have had some extra links in there. So I could have had a, for redundancy purposes, had a link going from switch 4 to switch 1 and another one from switch 3 to switch 2. And that probably would have been a better setup. I only just thought about that as a last thing, but could have been possible. And then you could have actually had this one as being the root bridge for STP for VLAN 10, and you could have had this one the root bridge for STP for VLAN 20, and that would have actually used those links efficiently and nicely, certainly. But yeah, with the Ether channel running, we don't actually have any loops, switching loops, but of course, yeah, so which means we do have some redundancy in that these links are redundant. If one of those cables were to fail, the link would still work, but only at 100 instead of 200 megabit. But of course, if one of these switches fails, one of these core switches fail, you're going to have some reduced connectivity, and so that those redundant links would have gotten us around that. But anyway. Okay, so that's probably enough for this session today. I'll see you again next time, and so the next topic we do is EIGRP, and so we'll actually do the 2 chapters for that next week, and that will be both the introductory and the advanced configuration of EIGRP, and that will be in one demonstration. So I'll see you then. Have a good one.